This is Anu. Me and my teammate Chandu worked on the project Insider Threat Detection dealing with feature engineering and sampling techniques. First, let me define insider threat. Insider threats are malicious acts carried out by the organization's employees who abuse the authorized access to systems and data through carelessness or revenge. For this project, we used CMU's CERT dataset version 4.2 as it has more insider threat incidents than the other versions. This consists of 4 different events: the log on log off events, email transmissions, device details, and file transmissions. So, here, as we can see, the ID here refers to user ID, date is the date of occurrence of the event, activity is the kind of activity that we are capturing, like log on log off activity or PC disconnect or connect activity. This is some of the previous work which was done in the domain of insider threat detection, and here we can see that the highest accuracy attained is 94.5% when using graph convolution networks, and the second highest is 94% using random forest with randomization. Now, coming to our research goal. So, we took the data and we see that there are like total 1000 employees in the data set, of which only 70 people are the insiders. And all the previous works done are lacking the balancing techniques. So, as this data is imbalanced towards non-malicious records. So, our research goal is to focus on these sampling techniques as well as on feature extraction and to compare our work with previous work. We also evaluated the accuracy post-balancing techniques. The first step which we did was feature extraction. We extracted 17 different features from the .csv files provided and then aggregated these features with user ID and date. We then counted the frequency of each feature for a particular user and identified them as malicious or non-malicious based on the criteria defined by us. Now this gave rise to a target column which says 1 for malicious and 0 for non-malicious users. So these are the 17 features which we extracted. So everything that ends with underscore normal are non-malicious. And here we are capturing details like if the user is logged in between 8 a.m. to 5 p.m. or a time afterwards. Or if the user is logging during the weekday or weekend. We're also capturing other details like if the email is sent within the organization or to outside the organization and the type of the files that are transmitted. We then proceeded to vectorization, and here we created a 3D array. So for every user, we created a 2D matrix with the 17 features as the rows and the number of days the user worked as the columns. We later on converted this to a 2D array which yielded us 9000 features per user in the data frame. For the sampling technique, we employed SMOT analysis, ADASN, which stands for Adaptive Synthetic Sampling Approach, SMOT plus ENM, that is editor nearest neighbor, and SMOT plus atomic links, which is a form of condensed nearest neighbor for the sampling techniques to balance the target classes. Coming to the classifiers, we selected logistic regression, SVC, random forest, ADABOST, and isolation forest, and CNN for our models because they are flexible and are adaptable, especially in the case of imbalanced datasets. So we evaluated all our chosen models on these 4 metrics, those are accuracy, precision, recall, and F1 score. So coming to our experimental results, we first performed SMOT analysis on all the selected models. Here, we can see that the highest accuracy attained is using SVC and logistic regression. So SMOT analysis, as we learned in class, adds synthetic data and is a form of oversampling techniques. The second method which we employed is ADASN, which stands for Adaptive Synthetic Sampling. This is also a form of oversampling technique just like SMOT technique, but here this takes care of distribution density. In this case, we see that CNN attained a highest accuracy of 96%, followed by logistic regression and SVC, which got an accuracy of 94%. The third method used by us is SMOT plus atomic links. SMOT is an oversampling technique which I previously mentioned. So, this can induce artificial data leading to the overfitting of the model. The atomic links here is an undersampling technique in which we choose random data from majority class, and if the random data's nearest neighbors is the data from the minority class, then it removes this. Therefore, the atomic links is a data cleaning technique that focuses on eliminating borderline instances that cause ambiguity. So in this scenario, we see logistic regression and CNN both attained an accuracy of 95%, followed by SVC, which got an accuracy of 92%. The last technique employed by us is SMART plus ENN. ENN stands for Edited Nearest Neighbors. So this is also a hybridization technique, and in ENN, nearest neighbor of each of the majority class is estimated. If the nearest neighbors misclassify that particular instance of the majority class, then it gets deleted. So this technique is useful because it focuses on eliminating noisy synthetic samples. During using this technique, we got 95% accuracy with CNN, followed by logistic regression and SVC. Both of them got an accuracy of 93%. So comparatively, we can see that our model, which is a combination of ADASIN sampling technique with convolution neural network combined, got us an accuracy of 96%, which is greater than the accuracy which was previously attained using graph convolution networks. In conclusion, we tackled classes imbalance using 4 techniques. And as we saw, ADASIN combined with CNN gave us the highest accuracy of 96%. Also, do note that CNN always attained an accuracy of greater than 92%, followed by SVC and logistic regression. Furthermore, we would like to explore other datasets in real time and also investigate deep feature synthesis in diverse domains. Thank you.